So last time we talked, we came up with the law of cosines. There are three versions of the law of cosines, and we distinguish them by, is it an a squared equation, a b squared, or a c squared equation? So the a squared equation looks like this. A squared equals b squared plus c squared minus 2, sorry, that's a b, bc cosine of a. What would the a squared equation look like? Or the b squared? The b squared would be a squared plus c squared minus 2ac cosine of b. C squared equals a squared plus b squared minus 2ab cosine of c. And this one is the one that turns into Pythagorean theorem when c is a right angle. So, yeah, you're going to be totally confused. Yesterday, when you were gone, we showed you where those equations come from. Okay, now you're up to speed. But you still need to go do that. Okay, so let's review really quickly. Law of sines. Law of cosines. Which three-letter combinations work for the law of sines? Angle, angle, side. Angle, side, angle, and angle, side, side. Okay? And then the other two don't. This one is side, 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 angle, side, or angle, side, side. So basically, the law of sines works when you have two angles. And the law of cosines works when you have two sides, except this one works on both sides. But I much prefer doing angle side side with the law of cosine with the law of sines. It doesn't matter, they both work, but it seems easier to me to do the law of sines. Of course, it depends on what you're looking for. If they're looking for the other side, then the law of cosines might be easier. If they're looking for the angle, then the law of sines is definitely easier. So, whoa. Right, that's if you have law of sines. So side, side, side will work for the law of sines if you have another angle, in which case it's not side, 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 it's actually angle, side, side. So, yeah, that's a good point. So if you look at your worksheet, I used to have one. Okay, here it is. Law of cosines. What three letters am I looking at in number 1? Try again. Side, angle, side. Will the law of cosines work? Yes. Now, we have to pick which one of the three equations do I want to use in order to find the missing side, which is side C. Do I want the a squared or the b squared or the c squared equation? C squared. How come? Because the only angle we have is angle C. And in the c squared equation, angle C is listed. In the a squared equation, A is listed, and in the b squared, B is listed. So, in this case, C squared equals A squared, which is, does it matter if I do 13 or 29? No. So you can either do 29 squared plus 13 squared, or 13 squared plus 29 squared, doesn't matter. Minus 2 times, it's these same two numbers. It's 29 and 13 times the cosine 13. You guys are so picky. Cosine of 41. Well, this is nice. I can just plug all that in. So, 29 squared plus 13 squared minus 2 times 13 times 29 times the cosine of 41. What does that number tell me? It's c squared, so how do I find c? Square root it, also known as raising to the 0.5. So you can use the square root button, but I'm lazy. So I just put exponent 0.5, and I get 20, that's 21, right? So c is 21. Okay? That wasn't too bad. Look down at number 7. All of these are side angle sides, right? 1 through 6 are all side angle sides, so they're all the same. Okay? But number 7 is a little different. What are we looking at? Side, side, side. And what am I solving for? Angle A. So if I'm looking for angle A, which equation do I pick? The a squared equation, right? The equation you pick, the a squared, matches the angle on the end. So the a squared equation ends in cosine A. B squared equation ends in cosine B, right? So how do we write it out? But we know what A is. We know what little a is. It's right here. It's 14. So 14 squared equals 9 squared plus 6 squared minus 2 times 9 times 6 times the cosine of A. You lost, JC? So A squared equals B squared plus C squared minus 2BC cosine of A. So that's the formula we're filling out. So this is A, B, C, B, C, big A. All right, now this is a little bit harder to do because now we're solving for A. So we basically have 3 groups of numbers we need to figure out first. This one, and this one. So 14 squared is 196. 9 squared plus 6 squared is 117. 2 times 9 times 6 is negative 108 cosine of A. Everybody get what I did? That's the formula. Formula uses subtraction. Good point. All right. So, how do I solve for A? Well, I need to move over this and this. Which one gets moved first? 117 using, it is addition, it's positive, so we're going to subtract. So 196 minus 117 is 79. Okay. Now what? Not plus. What's holding the 108 and the cosine together? Multiplication, the opposite of multiply is divide. So 79 divided by negative 108. How do I know that's a good number? It's between 1 and negative 1, right? So the cosine has to be between 1 and negative 1. So the answer exists, which we knew. Anytime you have side angle side, there is an answer. But when you get to this step, if you get one that says like 3.6, you made a mistake. Okay? When you get here, cosine of A has to equal some number between 1 and negative 1. So how do I figure out what that number is? Inverse. So the inverse cosine of, well, I'll just put answer, is 137 degrees. And we're done. Okay. Look at number 10. Okay, number 10. This one's a little bit tricky. Why is this one a little bit harder? What equation do I have to pick? No, I have to pick the b squared equation. Why? Because I have angle B. If I use the b squared equation, what am I going to figure out? Side B. Is that what I want? No. But I need B. How come? Right. So the goal is to figure out angle C. Well, in order to find angle C, I have to know side A, side B, and side C. Right? So the ultimate goal is to use the c squared equation so that I can find angle C. But can I use the c squared equation right now? No, because I'm missing side B. In order to figure out an angle, you need all three sides. So we'll have to do that in a minute. In order to find little b, I have to use the b squared equation. Once I know what that is, then I switch and use the c squared equation to find angle C. Okay? So b squared equals 29 squared plus 24 squared minus 2 times 29 times 24 times cosine of 101. All right. So I can just plug all that in. What does that tell me? That's b squared. So now I must take the square root, also known as raise it to the 0.5. So 41. Now, before I finish, does that number seem reasonable? Well, the short side is 24, the middle side is 29, and the long side is 41. Yeah, that could happen. This angle here is quite a bit bigger than the other two angles, which means that the side opposite should be quite a bit bigger than the other two sides. If you get an answer like 30 in this case, it's probably not big enough. If you get the answer of 5, it has to be wrong. Okay, now what do? We do the c squared equation to find angle C. So I do know what C is. It's 24. So 24 squared equals... Does it matter whether I use the 29 or the 41 first? No. So 29 squared minus 41 squared minus 2 times 29 times 41 times the cosine of angle C. Now, we need to figure out what these three groups of numbers are. Oops. This one and that one. So 24 squared is 576 equals 29 squared minus 41 squared. Oh, it's not. It's plus. Thank you. Keeping me honest, Dylan. This should be a plus. So 2522 minus 237, wait, 2378, cosine of C. Now what do? Subtract 2522 You might want to pay attention to this, JC, and not that. So 576 minus 2522, negative 1946 equals negative 2378 cosine C. Now what? Divide by negative 2378. How do I know that's a good number? Between 1 and negative 1. So I take the inverse. It's 35 degrees. So this is 35. Now, if you look, if you turn the page, number 13 says, solve each triangle. What does that mean? Yeah, we did it yesterday. Find everything that's missing. Right? Well, in this case, I'm only missing one thing. I'm missing angle A. Is that hard to find? No. So, when it says solve, for example, number 13, if you have side angle side, what's the first thing you can find? The other side. Now, if you have that other side, then you can start finding angles. And guess what? If you prefer the law of sines, you can use it. That was pretty cool. So, number 13. Which equation, which version of the law of cosines am I going to use? C squared. So C squared equals 27 squared plus 22 squared minus 2 times 27 times 22 times the cosine of 105. Now that's a pretty easy equation because I can just plug them all in. So 27 squared plus 22 squared minus 2 times 27 times 22 times the cosine of 105. What does that tell me? C squared. So I'm going to raise that to the 0.5. 39. Right? So this is 39. Now, I could use the law of cosines to find the other angle, but it's pretty involved to figure out a missing angle using the law of cosines, right? So now that I have all three sides and one angle, I can use the law of sines. So how would I find angle A? Sine of A over 22 equals, has to be sine of C, because that's the only other angle I have. Sine of C over 39, and then cross, oh wait, 105. Put a 105 there. Cross multiply, it's going to be 22 sine of 105 divide 39. 22 sine of 105 divided by 39. And that tells me the sine of A, so I take the inverse. Inverse sine of A, 33 degrees. That was a lot easier than using the law of cosines, right? So if you're solving the triangle with side angle side, use the law of cosines to find the missing side and then switch and do the law of sines. What about if you have all three sides? Like in number 16. You have to use the law of cosines to find any angle. So let's say I figure out angle B. Once you know B, what are you going to do? Switch to the law of sines to find C, and once you know C, then you just subtract to get A. Yep. All right. I don't anticipate you're going to get this done. Go to number 18 and stop, and we'll do the last 6 problems tomorrow. Okay? All right. Good luck.